All right, welcome in everybody. We're gonna give it a minute or two for people to come in and hang out. We're gonna kind of be talking about from VMs to bare metal. Do some intros real quick while we're waiting. I'm Mike Peterson, tech marketing engineer at Loft Labs, and this is Scott. You want to say hello, Scott? What do you do?
Hey everybody, I'm Scott McAllister, developer advocate at Loft Labs, and I'm excited to talk about this today because I want to hear people's opinions. I think this is kind of an opinionated topic, and I want to hear if the way we're thinking about things is wrong, or if you don't agree with us, or if you do. So that's what I'm excited about today.
Yeah, listen to our takes. Maybe ours could be a little bit jaded or something like that from it. Like we're sitting there thinking about like, oh, 10 years ago, like talking about this stuff and now talking about it again. I don't know. Like it seems like we've gone from bare metal to VMs and now we're talking about going back to bare metal. What does that even mean? Right? Like VMs make it super easy. Why would we want to do that? Well, let's go and hop into it, right? Since we're going to get started, I'll show the agenda, right? Like this is kind of gonna be like an open discussion. So yeah, if you have opinions, if you think that our opinions are wrong and you want to add your opinions, or if our opinions are wrong and you've got some facts, drop them in, right? Like interact with us, let us know. It's going to be, like I said, it's going to be kind of open-ended. Like I've got a couple of slides, but this is more of a discussion and talking about like what we see as the future. So we're going to talk about, vCluster plus vNode, your fast lane to bare metal performance. That's kind of the marketing hype of it. But we'll talk about like where vNode fits in, where vCluster fits in, and then we'll talk about some considerations. What you did in the past, what you did in the present, and then what you did in the future. Yeah, my hair's back. So it's slowly coming back. Like I was talking to Scott earlier, like literally, like I don't like going to get my hair cut, so like I'll let it grow out and then I'll shave it, and I'll let it grow out and I'll shave it. So it's varying lengths, and I need to shave back down to the mustache like the Rancher video. But
I don't either. I don't like the barber either, just to let everybody know. Like
yeah.
I like growing the hair out a little bit. So yeah. Thanks for noticing, Gray.
Your hair's got a little bit more flavor though, right? Like mine's kind of, it's just like boring and like stringy. Like if once it gets to a certain length, it'll start curling, right? But like it takes a while. All right, so I'll go over considerations and then we'll do like a little open discussion and then we'll come back. So past, we'll talk about all the hypervisors. Present, we're talking about VMs, to run containers, and then future, we're going to talk about, back to bare metal. All right, so let's go ahead and let me hand it off to Scott. Scott, you want to do more of a introduction of yourself and talk about these points?
Sure. Yeah. I'm as I mentioned at the beginning, I'm a developer advocate here at Loft Labs, and I've been around the block a couple of times with a lot of different technologies. Love open source, love cloud native. Been advocating for cloud native projects and technologies for a while now, and even a certified Kubernetes developer. And so just trying to learn. What I love about software, what I love about our industry is there's so much to learn and there's always opportunities to learn. And so that is what I love about working in this space is learning. So I hope to learn some things from you all today, but also share some of the things we've learned. So that's what I'm excited about.
It's kind of like it's a little bit of a curse that there's so much out there to learn, especially if you're ADHD, like a large amount of the probably tech population, because you get overwhelmed
to be in our space, right? Because there's just so much that you just kind of have to be like willing to context switch all the time.
Like a little bit about a lot of things. That's what I get to, because I'm getting a little bit deeper in this. This is boring. Let me go to the next thing, and then learn just enough to get the task done. I'm not the person that jumps into terminal and knows like 1,000 shortcuts, right? Because it's like I just want to get the thing done. Where there's some people that are more like, I don't know, artists, I guess you would call them. Like they're artistic in their terminal usage and their Emacs and all that stuff. I'm boring VI, now actually even VS Code, because I'm hardly ever, actually SSHing in anywhere anymore.
Well, the problem is VS Code is just so easy now. Like Microsoft really got that one right. And that takes a lot for a guy like me to say. I'm years and years and years anti-Microsoft, but Microsoft really got VS Code right. It's just lightweight, easy, really like it. And to go to your point about jumping different topics, I was taught once that I needed to have like a T, you know what I'm saying? Like you're broadly knowledgeable in a lot of things, but then you find those few things that you go super deep into. So maybe terminal, commands are your thing, or maybe Kubernetes ingress is your thing, or Kubernetes in general is your thing. But you kind of go deep in that, but then you go broad in lots of different topics. And so that's kind of where the balance that we find in the industry.
So let us know in the comments or like in chat or something like that if you have questions while we're going along, like if you want to ask something, or it can be about vCluster, it can be just about us, it can be about anything. This is kind of like a it is a webinar. It is talking about, you know, our subject matter, but it's also kind of a community thing where we just want to interact and like discuss the ideas with you guys. All right, so I'm Mike Peterson, technical marketing at Loft Labs. My background is open source. I started OpenStack around like 2012 or so. Actually migrated from VMware to OpenStack around that time because of how expensive the licensing was. This is going back all the way to like 2012, 2013. And then I moved from OpenStack into Kubernetes, and then I did some work on like Knative. Got to hang out with the chain guard people before they got huge, right? Like they were all Knative people and stuff too. So I'm super proud of them. But I like making demos. I like making videos, like doing webinars and stuff like that. You can find a bunch of my videos on our YouTube channel, and then you're going to see me on webinars and Scott too. So let's go ahead and before we hop, right into the past stuff, let's talk about like, why are we talking about bare metal and why are we talking about VMs and stuff again, right? Like, of course, some things changed over the last couple of years where maybe your licensing is getting way more expensive and you're starting to think about this again. Like maybe you're using, VMware, maybe you're using OpenStack or something like that, but you're just using it basically to run containers, right? So this is where this discussion kind of comes up, right? Like especially with GPU stuff and everything too, you're wanting to reduce the amount of workloads and everything that are running on each of the nodes so you can access that stuff and actually use it instead of using it all for VMs. But I kind of given away some of the slides here. So Scott, you spent some time recently looking into like all the hypervisor stuff. What's some of the realizations that you have as a developer looking at like what goes into like picking a hypervisor? And there's an article coming soon. You're gonna see it.
Yeah. The interesting thing, you mentioned trends and how the trends feel like they kind of started bare metal, went virtual, and now are kind of trending back to bare metal. And the part that I thought about is your initial knee-jerk reaction is like, it's almost like a fashion trend where like fashion kind of comes back around. The stuff that was cool when I high school, and now I see all the high school kids wearing like exactly what I wore in high school. We're not going to talk about how many decades ago.
Jinkos and stuff are back.
right? And so, and things like music, that kind of goes around. Like it goes from bands to techno to back to bands and then bands with techno and all that weird stuff. And so similar to software, I feel like that trend happened. However, I don't think it's a fad thing. I think it's more of a need thing. We went virtual and we have lots of great functionality with virtual machines. They've helped us have, like you mentioned, the hypervisor led us to hyper scaling things, running things very easily, either in the cloud environments or in our own data centers. And we were able to spin up lots of different machines very fast with minimal hardware. But now we're starting to get to a point where we're sort of evolving into this whole GPU era where we need to kind of get back to the hardware. We need to get back to efficiency. And so it feels like that's where the trend's going. Maybe I'm giving away the ending as well. But that's kind of what I've been seeing. In the research I've been doing is that people are looking for efficiency rather, or I guess at the cost of the ease of expansion and things like that. They need things to run fast and run well, and not to be abstracted away from that hardware. And so a lot of the different hypervisors that you can have different types of hypervisors. There's hypervisors that are right on the hardware. They call it bare metal hypervisors, or type 1, as I've learned. And then there's the type 2 hypervisor, which actually sits on an operating system. And when you think of type 2 hypervisors, a lot of the times you're thinking of things like Oracle's VirtualBox or VMware's Workstation, where you're having it locally on your machine or like a development environment, or just easy to spin up environments that could still be a server environment, but it's probably not, you're not worried about efficiency as much. The type 1, those ones are a little bit more, they're a lot more closer to the hardware, not running on top of an operating system. And so they're going to be a little bit faster, a little bit more responsive, a little bit more tucked in or attached into the hardware. And so that's how I've learned about hypervisors. Now, Mike, tell me about ESX and KVM. The vendors are the things that I don't know a lot about. So tell me about that.
All right. So I guess the journey of all this stuff kind of starts maybe late 2000s, right? Like late 2000s, early 2010s and stuff. Everyone was looking at like, how do I move, all of these things that I'm running from a single server to virtual machines. And like the big ones you kind of were looking at back then, like you had like Zen, you had Hyper-V and stuff, but for the most part, you're either going to be like an ESX shop, so VMware, or you're going to be KVM and you're going to be running on Linux. Maybe you're using like the Red Hat Enterprise virtualization or things like that before OpenStack and these other things came out, right? You're just running that. Now, I mean, you have like all these other options and stuff, but like back then that was kind of the idea. My ESX and my KVM. ESX was awesome, because there was a whole training program and stuff around it. VMware had all of their events and stuff, and you could go get trained, learn how to use vSphere. People that were moving from maybe like Windows or something where they had like a great UI to be able to point and click and set stuff up. It was much easier to configure everything. You don't have to do anything on the command line, really. You just installed ESX on your node, and then you brought it into vSphere, and then you could do whatever you wanted, right? Like, so that was super easy. But even, back in like 2010s, super expensive, right? Like, you're spending so much money on it. And if you're, a small shop that's just trying to get started, that price might be too much. So maybe you look at KVM, and then, you're like, what do I use? Right? There's a couple of things that were out back then that got purchased by like people like Oracle and stuff like that, where they were trying to build, the Amazon cloud on-prem. There's like something called like Nimbula, and then like all these other projects that came out. Well, those got bought up by all the large groups and stuff, and you didn't have that option anymore. OpenStack kind of came out and took over. That's kind of the next slide. But basically, you could either have point and click kind of with vSphere, or you could have like Linux administrators. Each had their different trade-offs. Like, one was super expensive and the other was super expensive too, right? So they're both super expensive. It's just like, where do you want to spend your money, on your people, or do you want to spend your money on your software and then just use that training program?
Is it accurate to say that one was the kind of the vendor and the vendor route going with VMware, and then KVM is going the open source route? And so right.
Yep.
Okay.
Yeah, so one's vendor. Go ahead.
Yeah, I was just saying, and so with that one, with the vendor side, yeah, like you're saying, you're putting your cost into someone else or into a product, and it's a little bit easier to run. Like, it sounds like, because like you said, point and click. Which again is efficient and it's fast. However, it feels like with open source, with the Linux administration type folks who would be running KVMs, that you could have a lot more control over it, right? You could get it to do what you want quicker.
Point and click might be a little bit, reducing of what it actually takes to do something like, vSphere, because you're still learning, about storage, about your networks and how to configure that. You need to know about like how VMs are actually working and how to do templates and how to actually build the operating system and stuff like that. So I say point and click, like, because I'm considering like a UI versus like the command line or something like that. So like point and click might be like, I don't know, derogatory or something like that. But when you're talking about it, but it's not really that. It's just like, it gives you good UI, makes it easier, and it reduces the thing. Because I don't know if you've tried to go set up storage on a Linux machine versus vSphere. Like, on a Linux machine, it's annoying every time. I always have to go search and find the right commands. I have to use parted and all this stuff. It's annoying if you just want to be able to set that up for like a large amount of machines, right? Like, it's still a little more difficult for bare metal. But yeah, so UI and ease of use could make it expensive. But then also, hiring a bunch of Linux administrators can be expensive too. But then, you're kind of putting your money in your people, and then you're not really locked in, because there's many different options for KVM, right? Like, you have OpenStack, you had Red Hat Enterprise Virtualization, you have basically anything that'll run on Linux. There's a bunch of vendors and stuff that sell things that you can run this on. And then you would oversub to maximize usage, right? So that was the sale of VMs, is let's put a bunch of virtual machines on these bare metal nodes, because these bare metal nodes were previously running like a single application or a couple of applications, and you're wasting all this space for just a couple of things that are running. You're probably not hitting 80% usage or anything like that. So what you would do is you would oversub all these virtual machines, and then maybe you've got like 20 or 30 virtual machines on a larger server. And the thing they don't tell you is like all that usage and stuff you're seeing is just to run the virtual machine. Like, there might still be a single service running on each of those virtual machines. So what have you done? You've taken a node that was running 1 or 2 services to a node that's now running 10 to 12 services or 20 services, right? Like, that's not really hugely efficient. It's not the greatest. All right, Scott, before we go to the next thing, you want to comment anything else on these ones?
I actually had a question, because again, this was a time where I was a developer, you were more of an admin, so you have the focus of knowing this space, especially the history of it all. Are we talking, this is a time before like APIs and infrastructure were a thing? So infrastructure as code wasn't really a thing. So we still had to do things by hand and manually, sort of thing, or just with bash scripts? Or is this around the same time as all that, the rest of that?
So kind of like, you were templating and stuff before, right? So like your history, like, I'm not going to give away your whole article, but their history, like before it's just like setting stuff up and it was all by hand. And then you kind of got into like templating, right? So templating, talking about like VMware, if we're talking about KVM and libvirt and that kind of stuff, we're more so talking about, like cloud init and like configuration through automation in that way. But it's still kind of more of a manual configuration process to set everything up. You got to set up that cloud init script, and you got to say, I want to, import my SSH keys and all that. So it's before you get to the Ansible and before you get to that stuff, before Terraform and all that, to
Yeah.
where you can create stuff and it was API driven. You had stuff like HP automation and stuff like that to manage nodes before you could do like all this other configuration setup. You're still pixie booting and then like deploying an image and stuff to it. So a little bit more manual. VMware kind of made it a little bit easier, right? Because you could template stuff out and then just go deploy it. Cloud Init might have been a little bit more complicated for people when they're getting started, but Cloud Init's kind of more what you see on Amazon and stuff like that. And so hopefully if you use a cloud image before, you know what Cloud Init is, you know how to set up some of the configuration and get your VM configured, at least to have the operating system and your SSH keys, and maybe install a couple of things you need before you took it over with Ansible. But back then it would be like Puppet and Chef and that kind of stuff, which is just kind of coming in. If we're talking about like early 2000s, like you had like some of the Puppet and the Chef stuff was coming out for configuring OpenStack and your other services, and all this stuff was catching on and it was getting huge around like 2010 to 12. I have another interesting story. So like around 2013 or so, I went to a VMworld, right? Like, and Cisco sold us this idea of every single piece of hardware in your rack is going to be the same exact thing, and you can use it for anything, right? Which was like, they were thinking about VMs and stuff like that. Well, you can use it for VMs. You could use whatever node you want for like for storage. You put a bunch of drives in there, but it's the same form factor. You can use it for networking. You just got to put a bunch of network cards and stuff so you can actually interact with it that way. Like that was the what they were selling us, but we didn't really get there until Kubernetes came out, which we'll move on to in a like a slide or two. We didn't really get there until Kubernetes came out to where we could actually kind of configure that stuff. But then we still have network devices and we still have like all these other things. So that was one thing I got excited about in the early 2000s, thinking that everything could be the same, but not everything can be the same. Some pieces of your hardware are still going to need to be dedicated to network and stuff because of speed and how fast they are, InfiniBand and that kind of stuff. Like you're probably not just setting that up on a server. You probably have like devices. Let's go ahead to the next slide. And then Scott, if you want to add anything into while we move to the
well, no, the next slide is kind of talking about the evolution, right? The evolution of things had to progress, things had to evolve on the virtualization standpoint, but also in software development. I mean, for everything to come together as we have it today, we kind of had to have advancements in both areas. With hypervisors, that made it great to virtualize, but folks were still having huge code bases. Like and huge code bases are still around today. And it's not like monoliths have gone away, but they were the thing. They were basically all we had. And so folks started thinking about things in a little bit more different way, making their software a little bit more nimble, code-wise, right? Condensing things down into services, making things in a service-oriented sort of way, even going with microservices where you're putting your services even into just simple functionality so that you have very specific functionality inside of each of your bits of code. And so you want to have separation of your different functionality inside those services. And so again, that you wanted that all running. And again, it all ran on virtual machines just fine. Still does run on virtual machines just fine. But the thing with that is, as we kept progressing towards a world where we took, we have these services and now they're going to be, what about if we run them in their own encapsulated areas? Because each of those services have dependencies. They have libraries that they need to be using. If I'm going to be building a service in Node, I'm going to need the Node runtime. That's not a runtime. What is that technically called? The Node engine to basically run it, right? You need V8 to run that Node code. And then, but then if you're going to have another service that's Java, you need the Java runtime, or you need .NET if you're going to run C#. And so each of those have different dependencies. And so they would require different environments. And so that's how we have containers, right? We have containers that have the dependencies that made it possible to run our different services in isolated, but then interconnected with each other. And then we have that progression, right? The progression where we have a whole load of containers that they need to be corralled essentially. And that's
so what was your experience, Scott, during the time of VMs, like VMs coming in, right? Like you were a developer. Yeah. Were you consuming virtual machines? Was someone just handing you a virtual machine to go work on, or were you developing locally, right? Like, and then you were just like shipping the code and they would just deploy it for you. Like, how did it work in the 2010s for you?
Yeah, it was more I had my own development environment that wasn't a virtual machine. Although there was actually a few jobs where I had a virtual machine and I didn't love it. And they were virtual machines in the sense of more that type 2 type of virtual machine where
you're using VirtualBox or Vagrant or something like that.
Yep, I like a VirtualBox that I would run things in because I believe I was on a Mac at the time, and I needed to run things like we were using precursor to Git that was the Microsoft product. I can't remember what it's called now.
So at SVN before that? I don't know if
No,
people
it
can
wasn't
comment too.
SVN. It was the something in between. It was like TeamViewer or something like that. Someone in the comments remind me what that is. But it was like a whole thing. It was version control, but it was proprietary. I believe it was just to Microsoft. Yeah. Someone in the chat remind me. And so, but using that, we had to use our whole like deployment process was kind of part of this kind of Windows stack sort of thing.
Gotcha.
And so, yeah, that's how virtual machines were for me at that time. And it was more also, I was way into web developer. Yeah. Oh. Team Foundation. I think that's what it was. Thanks. Game over, Dave. And so at that time I was full stack web developer. We really used virtual machines more to do testing, more to do like making sure things ran in IE and things like that back, in the days when IE was very different, not Chromium based. And so those were the types of things we would use VMs for, really, is to make sure our applications ran on different environments.
I think so. Like every generation takes for granted how much more manual intervention and difficulty there was in the previous one. But then also, like, I'm not going to downplay like people now, because like 10 or 20 years ago, you could specialize and you could be specialized in a single thing and be really good at that. But now it's like everyone expects you to be like full stack and know everything, right? Like you need to know networking. You need to know like how computers work. You need to know Linux and all that stuff as a developer. You need to at least have a concept of that, right? It's kind of harder to go back to like, 15 years ago, developers like, I don't care about the network. I'm just going to develop this. And then you figure that out. Or like a Linux administrator was like, I don't care about the networking. All I know is that they plug me in and this is my IP address. I don't know the network stack. I don't know even what, network I'm in or how to get out. So like, now it's like we
compiled our applications into a jar file and literally shipped them over to the ops team and said, "You deploy it. I'm going home."
Yeah, like,
right?
Well, it works on my machine.
How our team worked.
That was the thing, is like I was supporting some Java developers and stuff probably around 2013, 2014. This is when I go back this time is when I had like a lab and I was managing a lab for a company and supporting developers. Well, they would develop locally with Eclipse and they would have Tomcat, whatever version they wanted. They'd have whatever version of MySQL or something that they're running. And I was trying to get them all to use CentOS, right? Because I wanted to be able to translate this to Red Hat if it was running in production or something like that. Didn't work, right? Because, the CentOS previously, like all of like the MySQL versions and stuff were super old, right? Like if you wanted to install something newer, you have to do it from source or something like that. Whereas like Ubuntu and stuff like that had everything new. So I went from being like, I'm going to make everything Red Hat to Ubuntu. And that was like one major step to switch to that, to realize that, this is going to be difficult to support. Now handing those users their own virtual machines and trying to set up Eclipse and stuff to just deploy there was its own thing in there, right? Like it was very difficult to support. Like I love containers compared to that. Like VMs, I wouldn't go back if I didn't have to, but that brings us to the present. VMs to run containers, right? Like now we're maintaining virtual machines just to run containers. Right, like so, not 100%.
Does that make sense, though? No. It wasn't that the whole point of containers. Nope. The whole point of containers was to be able. I could run an application in any environment because everything it needed was inside the container, right?
Yep. Well, so we'll get to the next slide. I'll kind of talk about too, but we're maintaining these VMs to run containers because we're trying to create secure environments so that we can give different tenants access to things and pretend like they have access to bare metal nodes or access to their own virtual machines and stuff like that. So like, it's a lot to maintain if you're a platform creator or like a platform engineer or something like that. You have to maintain all these virtual machines. You have to make sure that they're up to date. You have to make sure that you've got all of the packages up to date and stuff like that. And then on top of that, you need to make sure that Kubernetes is up to date. And then all the CRDs that are running in Kubernetes are like up to date. But like, hopefully that's changing.
Right? Because like the more we abstract, the more we have to keep track of. Especially now, like you were saying, like with full stack, a full stack engineer, just being in charge of a stack. You could have a team in charge of a stack. Before, like you said, I didn't need to worry about lots of different things. I had code, it ran, it compiled, and we deployed it to a server and it ran, in an environment there, either Tomcat or Apache or something. And then there was a database. That was about it. Now we have like message brokers and all that stuff. And that's, and then we have all sorts of different layers of different products that we snap together in place to make sure our applications run, and we're running on different nodes and running in different clusters and running in different parts of the world. And it's a lot.
Well, that's why I keep my hair short, so I can't pull it out.
Exactly.
I can't grab onto it. All right. So like So what are some things you're thinking about in the present right now? Like you see all these messages coming out and marketing and messaging about, hey, go from VMware to OpenStack, go from VMware to KubeVirt, but if you're running mostly containers, like say like 80% of your workloads are just containers, all you're doing is adding overhead to what you could be running on bare metal by just having these virtual machines, right? Like the cost to stay on VMware or something like that is super expensive. The cost to stay on OpenStack is also expensive. In that you've got all the time invested and the people and stuff like that, making the transition is going to be difficult, right? So the cost to move is going to be expensive. OpenStack doesn't have the licensing, but you have the people requirement. You have to be able to troubleshoot, virtual networking. You have to be able to troubleshoot like 10 different services depending on how much stuff you have installed. I remember one of the largest OpenStack clouds was like Walmart back in like the mid 2010s, and like they were bragging about, oh, we've got, it's super easy. We've got like all of these nodes and stuff. And they were literally using like the easiest version of networking you could use, which was Nova Network, which was a flat network, which was kind of like EC2 used to be, where it was just all a flat DHCP and everyone was in the same network and you didn't give each person their own virtual network to keep them separated, right? Neutron came in and then Neutron made it super difficult. So like basically troubleshooting OpenStack in like the mid 2010s, maybe it's a lot better now. Like I've been disconnected from that since I moved to Kubernetes, was a lot of troubleshooting RabbitMQ, right? Because there's a lot of things being put on the message queue to say, go do this, go do that, go do this. And that's how all the services talk to each other in the database. Or it was a networking issue. Like you got too large and then the virtual networks would just break, right? Like, so like either we're troubleshooting that every week or we're troubleshooting message queue issues every week or something like that. For the most part, it worked. But like the complication that came with it made it super difficult to install, super difficult to maintain. And that's why you had companies like, I worked at Mirantis there to actually help and fix stuff. Now there's other companies that have come up around OpenStack, but it was just super difficult to maintain. So,
but didn't we make those decisions? Like how we get there? Like how do we get to a spot where we look around and say, what am I doing? Right? You're looking around like, look at all these things I have to now keep track of. But we got there because of familiarity. We were saying, well, I already know how to run a thing on a virtual machine. So, and it's doing just fine. So I'm just going to start putting these containers on there. And now, oh, there's this Kubernetes thing. Oh yeah, let's start putting that on there. And now you have a process where you say, here is how we do this. And you're really thinking about what's here in the stack of what you're dealing with every day. And you don't really remember, or at least you don't focus on those layers of the stack that are below you that are things you have to keep in mind. So you have all these virtualization layers that you're saying, oh, wait, we have to now spin those up so that we can also spin up these containerized layers above.
Well, the concept is like, it's easier, right? Like, and also, yeah, going from bare metal to VMs, it's maintaining the same thing. The tools that you're using are the same. You're using the same tools to maintain those, right? Like it's easier to spin it up. You're not actually having to do the pixie booting and all that, but you need a cloud image and stuff like that. So it's faster. But yeah, if you're just running containers on that, then it's like, what's the point? What's the point, to do that? Like if you're moving from one VM solution to another VM solution, you might reduce, licensing costs, but you're not reducing any of the overhead that goes into maintaining those virtual machines and making sure that they're up to date. Right. Like, and then you can oversubscribe, like, which is going to help with utilization. But so much of that usage is just dedicated to the virtual machine, right? Like you've got all these virtual machines running on there, like, oh, I'm using my server 80-90% of it. And then I need to get some new servers. Maybe that's good to justify getting more hardware, but it's mostly the virtual machine, right? Like maybe that single service or something that you're running on there, or that jar that you're running with Tomcat, right? Like unless you're running multiples on there, like that's just so much overhead just to run this single thing. I'm not going to say, Kubernetes is the best way to run like a single like website or something like that. You don't need Kubernetes installed just to run a guest
single container. Right? Like,
yeah, it's not the best idea either, because there's still overhead with like Kubernetes, right? Like you might not need all of that. Like if you're just running a website.
Right. I would love to hear the folks that are watching.
Yeah.
Tell us in the chat, what is the point? Right? Like we're asking, what's the point of running containers on VMs and running Kubernetes on VMs? But if you're doing it, why? Tell us. Like maybe we are missing something. So let us know.
I think like instead of changing the trajectory, right? Like when Kubernetes came out too, everyone was already implementing a virtual machine strategy, right?
They were familiar with it. This is what we do, right?
The vendors are like, hey, everyone's using it. Yeah.
Yep.
Vendors like, hey, they're using it. Let's make plugins. Let's keep making them use this other thing. So like literally there are people out there, maybe you, I'm not judging, but there are people out there that are running VMware, right? And then they're using the OpenShift too, and a plugin for OpenShift to make it so that they can deploy more nodes and stuff like that with VMware. How much does that cost? Like, that's so expensive, right? Like, I'm using VMware to create all these VMs, and then I'm using, OpenShift to be able to create and maintain stuff and everything too. And like, there's so much licensing that goes into that. You probably do need the enterprise support and that kind of stuff too, but it's just so expensive. Like, and then they're also using cloud providers. So it's like, how much of their stuff is just going into maintaining these virtual machines and making sure that that works, when the actual upsell of Kubernetes back when it came out was that you could use, any node and just join it in, and then Kubernetes can just run stuff on there without having to think about virtual machines or anything like that. Like, it was like, turn all of your nodes into this Borg, into this one thing, and deploy stuff everywhere. All right, so we have one. I'm using K3s on Bare Metal and also in VMs. K3s and Bare Metal works great. That's what I have too. I'm using a little bit of both, right? VM tax is real. Yeah. So I've got a DL360 from 2010 or something like that down in my basement. And I'm using Proxmox. I was using LibVirt with the Terraform provider and deploying there, but a little bit less support there. So now I'm using Proxmox. And then I'm just installing
so hot right now, right?
Yeah.
Like, everybody
so
I
easy.
know, everybody I talk to, especially home labs, Proxmox is like the standard of what people are doing.
Well, so many people are using VM, or they're using Kubernetes and stuff for their home labs more so than what they did previously. That, like, I've been watching a bunch of home lab videos and stuff, and I was like, everybody's using Kubernetes. Like, so I want to make videos about, like, hey, take it to the next step and use vCluster so you can use different CRDs and you can install different things for it, right? Well, I'll upsell that in a minute. But yeah, basically all the home lab stuff's now Proxmox. So like, I'm using Terraform, I'm deploying my virtual machines, and I'm running K3s on my virtual machines there too, right? I was running it just as a single bare metal server with K3s and running it that way, but I wanted to be able to test some more things. So VMs are still useful, I guess, for testing things. Like, if I want to test setting up Ceph with Rook, I don't necessarily want to do that on bare metal first. I want to do that with virtual machines so I can clean up and I can modify it without having to redeploy an entire bare metal node that I've messed up for storage, right?
Right.
So like,
well, and I want to argue, VMs aren't all bad, right? Like,
no.
it's not like everyone needs to run away from them, but it's the fact of, like, just question why. Why are you using it in this particular situation? Why are you running a Kubernetes cluster on top of VM? Is it because you need to? Is it because there's an actual benefit to you besides the fact that it's just what you've always done? Or is it just what you've always done? Could you be doing something better?
Some stuff's so legacy too that, like, they don't even create it in a way that makes it available to run outside of a VM. Like, there's some things that, like, there's still stuff running probably, like, it was government contractor for a while. There's probably still stuff running government contract stuff that's like, it cannot run on a VM because they have not created an image that will allow it to be deployed on a VM that's checking for specific flags to make sure that they have things enabled on, like, hardware.
I can only imagine working in government technology. Like, you're very set on what you're doing. So
they're getting faster. Okay, so Game Over Dave says he's using KubeVip. So like, I'm using Metal LB. I haven't actually tried KubeVip. Heard it's great. I use Metal LB from like many years ago, so I'm just used to it.
Mike taught me about Metal LB. So I set up a home lab recently. We talked about it on the last time Mike and I were on a live stream. So yeah, game over, Dave. I'm also running K3s on Ubuntu in my home lab. It's fantastic. It's been running great. And I have it set up with Argo so that I can just redeploy my applications, because the power goes out in my house. I live in Western Washington, and so outside Seattle, and the power goes out fairly regularly. And so I have to kind of deal with that but that recovery sort of situation. And so that's important to me. But Mike turned me on to Metal LB, which has been fantastic, right? It's been able to make it so that I can easily give my services IP addresses, and then that way I can hook up my ingress to that and then serve those out to the world.
And we're just using like the layer 2. We're not using like any of the actual real HA stuff, right? Like level 2 is not HA, like it'll fail over, but
home lab stuff
for fun. But yeah, I've got that set up, and that's what I usually run all my demos and stuff like that on, so that I can get like local IP addresses. We were even talking about doing like port forwarding, so Scott could do like a website and stuff like that. But then, using Kubernetes and port forwarding is not necessarily what you want for just a website, right? Like when you can do a couple of easier things.
Exactly. And it's, again, it honestly goes back to familiarity. I mean, to the fact that, like, where I've been taught, where I've come from, ngrok was a fine tool to get websites out of my house online. And so I've been using ngrok's Kubernetes operator.
Which tunnels in.
It does.
You don't have to trust people.
Honestly. And then, like, so I got Excalidraw, because all the cool kids here are using Excalidraw, and I got that running on my home lab. And rather than just serving that out to the world, I was able to actually put OAuth in front of that, so it only accepts my email address. So that's kind of nice.
Right.
But yeah, Dave, yeah, Metal LB is great. I used Metal LB before I started using Traffic. Oh, okay. Tell us about Traffic, Dave. I haven't used a lot of Traffic. Mike, have you used Traffic?
I disable Traffic on K3s.
Yeah, because that's true, because Traffic's built into K3s.
Yeah. Whereas like with Traffic, I was messing around and I couldn't figure out how to do like an entire IP address pool, but because I already knew Metal LB, so I just deployed it without, and then I just set up Metal LB and got that working. All right.
Nice. Okay,
while Dave's giving us some information, I'm going to go to the future, right? This image is confusing. That's why I put it up there so you can stare at it while we talk. So, you know, the future, back to bare metal. And 5 years ago, if you asked me if everybody's going to go back to bare metal, I'd be like, probably not, right? Like, why would you want to do that? Like, you want the VMs to be able to do the pass through to your devices and stuff like that, and then share it up if you want, so that you can have a little bit more security and not worry about people having to try to run privileged workloads, right? Like, previously, all of your containers that needed access to a GPU or something like that needed to be privileged, right? Like, not as much anymore, right? Like, there's ways to get around that. But, you know, the VMs with the pass-through, stuff like that was a way to get around it. But now everybody's more so thinking about, how do I run these workloads and get access to GPU and the underlying hardware on a machine? And how do I reduce the amount of things that are running on that machine that I don't need running there, so I can have as many things running and accessing those GPUs and making sure that I'm getting the most out of them. I mean, when you have a machine with like 8 $15,000 GPUs, you're not going to want to run a bunch of virtual machines, and like, you know, 30 to 40% of the usage is just taken up to run those virtual machines, and you're running containers on top of them. Like, it's too much. Now, a lot of people are using virtual machines and stuff like that to access the GPUs and stuff still. Like, there's a little bit of a mix. Like, Kubernetes is coming on. People are starting to think about using Kubernetes. Some people are like, well, maybe I'll use KubeVirt. But now, you know, within the last 2 years, NVIDIA put out the driver to where you can actually access it, and you can do fractional GPUs and stuff like that, which I learned, as long as you have a data center level graphics card, right? Like, I just built a new computer, and like, I've got a 5070 Ti. I can't do multi-instance, you know, GPU. I can't do some of the things that I can do with Kubernetes, but I can do time slicing and some of the other stuff. So hopefully we have some stuff like that coming out here soon, kind of showing off some demos. I'm working on a demo on how to show how you can actually use Kubernetes, vCluster, and vNode with a GPU, and do a little bit of I don't know, training or something fun. So we'll have that in the future. We'll share it with you. We'll share it with Scott first, so that he can learn it with me, and then we'll share it with y'all, and then we'll do like another webinar.
Yeah, need to dig into GPUs. GPUs is like that thing it's getting to the top of my stack as far as things I need to, that I'm gonna be learning, and GPUs is like right there to learn about all those types of things. And so I'm excited about the things that you're discovering, and hope to get my hands on some good hardware so that I can do the same thing. But yeah, super excited to see how vCluster and vNode also work with that.
Yeah. Thanks, Dave. Yeah, Dave just subscribed. Yes, if you want to see more stuff like this, just like and subscribe. You can follow us on, like, YouTube's probably where we're gonna have. Like, you can follow us on LinkedIn and like everywhere too, but YouTube is like gonna always have like the videos after we do them. We'll upload them there. Even if we do like a webinar that's like gated or something like that, we'll upload it there so that you can see it. So yeah, follow us on YouTube. Check it out there. Subscribe if you want. Right. So like, this is, like I said, this is kind of like some of the stuff that we do, but this is more of like Scott and I like doing it with Scott. The more of a community focused thing where we interact and we talk, and we just like bring up subjects and talk about vCluster and that kind of stuff. So some of it's going to be like more, I don't know, sales, marketing, like webinars, but then a lot of the stuff's going to be hopefully a little bit more fun and entertaining, so we don't bore you. All right, but let me talk about the slide real quick before, like, I just leave this up and everyone's like, what are you going to talk about? So back to Bare Metal.
Tell us about this pretty picture, Mike.
Yeah. This pretty picture is actually drawn by our CEO, and it was used in one of our previous webinars too. It just kind of give like an overview of all of the I'm gonna say, oh, it's easier to use Kubernetes on bare metal and stuff, and then you look over at this image and you're like, what is all this stuff? All this stuff like, is what goes into it after the fact, right? So you're already managing all this stuff, and then you add VMs on top of it. But like, basically, you know, back to bare metal, you're filling each node with actual workloads, right? Like, how awesome would it be to actually fill those nodes with workloads instead of just running VMs with a workload on top of it, right? Like, so you can do bare metal Kubernetes with vCluster. What does vCluster add in? vCluster adds in the ability to add in multi-tenancy, right? So we kind of had some use cases in the last 3 or 4 years where people were like, I want to use vCluster on bare metal to do multi-tenancy and give access to GPUs or give access to other things. The issue there is trust. How much do you trust the users? Are they internal? Are they customers? If you want to do a customer-driven thing, you need to have security. And vCluster does inherit a good amount of security from Kubernetes, but previously, if you had to run privileged workloads, you could still escape out, just like you could with a Kubernetes pod that's not locked down. You can escape out and get access to the node. Well, that's not really that great of a thing to be able to do, right? So we needed something that was in between those two things to kind of steal that, which is what vNode is. So like vNode adds in extra security. It runs on your cluster on each of the nodes as a daemon set, and then what it'll do is it'll set up this layer between your pods and the bare metal machine. So we've got a demo on the vNode website. I'll bring up the vNode website and stuff like that too, where we're showing like the difference of escaping out of a regular pod versus a pod that's running in vNode. vNode steals that traffic and it keeps the users from being able to access the bare metal node and access your network, access, you know, other services that are running on it and stuff like that. So like that's why we're talking about this now, right? Like we recently released vNode, I think a couple months ago, like 2 or 3 months ago, and we're still building on it and adding more stuff. It's in beta right now, right? Like so vnode.com if you want to actually try it out and run it with vCluster. But if you don't need that security and you do trust your users, then you can use something like vCluster to split it up and do multi-tenancy. All right, I've been talking for like 2 or 3 minutes straight. You got anything you want to add in, Scott, before like I just keep on going on for like 5 more minutes?
No, I think this is it's good things to know. I think the vCluster is definitely secure, but like you said, vNode is just an added layer of security. It makes it kind of the old Offspring song comes into my head. You got to keep them separated, right? And so it's like you gotta vNode is taking that separation from the cluster and up to the node. So now your node is completely encapsulated rather than just the vCluster.
I'm going to go back to the other side a second. I just wanted to add these up. So people are like, what is vCluster? What is vNode, right? So here's our definitions of vCluster. So vCluster is virtual clusters that are Kubernetes distributions that run as isolated virtual environments nested inside a physical host cluster. So if you don't know what vCluster is, literally it just brings a pod up and it creates a new API endpoint and it runs its own version of etcd SQLite by default. And it gives you a different API that you can install different CRDs into. All of your workloads still run on the base Kubernetes cluster, so there is no hypervisor or anything in between, right? Like that's the upsell. vCluster is open source, but you can do a ton of stuff with the open source version. And then there's like a paid version that adds some like the enterprise and like nice to haves and stuff like that, like being able to give your users ability to deploy their virtual clusters. And then vNode is a multi-tenancy container runtime that provides strong isolation between workloads using Linux user namespaces and seccomp filters. So vNode is now the enterprise like paid product. You can get a beta of it and check it out. But vNode kind of adds, it's kind of like, I think Kata containers and that kind of stuff. But if I'll show you the website in a minute, there's some things that vNode does differently instead of doing micro like VMs that should hopefully increase throughput, right? They're a little bit lower to the ground than the micro VMs. So you give it a try it out. I don't know what to upsell it. Like
on the point of vCluster open source and the paid version, I'm actually running the open source version on my home lab and have been pleasantly surprised with everything that I've been able to do. I think I have 4 vClusters running up now with 5. I might be 5 now because I just added Grafana on there. So it's been fun and so easy to get fired up and to get running and then get ingress easily syncing in from the host cluster into each of those vClusters. That's been very nice.
Pretty much. Yeah. Okay. So I'm gonna go back to the slides then so we can get off of that and we can actually look at the docs and I can show some other things. So
sounds good.
I'm jumping around. I am ADHD. So like if I jump around too much, hopefully it's entertaining. Hopefully it's not like giving you whiplash or something like that. So with Bare Metal, it's easier to access the GPUs and the network and the other stuff without adding that virtualization layer in between, right? So like if you want to have access to the GPUs, then you don't have to actually have a virtual machine, do pass through and then make sure everything's working there and make sure that like you have access to it. Instead, you can just give access to it, right? And then with the creation of vNode, now you can secure the containers and allow privileged workloads without exposing the entire host cluster, which that privileged workloads are important for some use cases. They were, like I said, more important for GPUs previously. Still, some people may actually want privileged workloads to be able to access the GPU and stuff, but it seems like a lot of the work that's going into Kubernetes and like the NVIDIA stuff is making it so you might not necessarily need that for everything. But it's nice to have that layer in between because there is the question every time that we get with vCluster is like, hey, how secure is it? Well, it's as secure as Kubernetes is, right? Like, so the vulnerabilities that Kubernetes have is more so inherited. So like however secure your Kubernetes cluster is and lockdown that is, that's what vCluster is going to give you because we inherit a lot of stuff from there. You can do some extra stuff in vCluster to like lock it down. But for the most part, like you need to make sure your Kubernetes cluster itself is secure. And
that's because as I've been heard it described recently, I think it was our CEO, Lucas, was explaining on a podcast once. It's because there's all these different
ways to do similar things, right? Making clusters inside of clusters and whatnot. But when it comes back to vCluster, vCluster is doing it the Kubernetes way, right? Like it's using Kubernetes to be a feature inside of Kubernetes. So that way, if you're the way you're already setting up your cluster, the way you're already configuring things and configuring your security, it's already all there. It's already something you're familiar with that you should be doing anyway. And so it's just an extension of that functionality.
All right, cool. So that pretty much that's the slide. I'm not going to talk too much about the graphic. It's there to confuse and look pretty and be awesome. I mean, that is like showing kind of like how vNode is on your bare metal cluster, gives you access to GPUs, and you've got all this stuff in between. What we should suggest for network isolation. So like if you mean virtual cluster layer, like the virtual clusters have the option to be either isolated or open, right? Like, so you can isolate it so you can't see stuff around you if you want, or you can leave it open to where it'll be just dependent on whatever you can share within the host cluster. But for the most part, you can lock it down and then not share much information about the host cluster up to the vCluster. You have a lot of control over what you can do. So like, I was going to hop to the docs here in a second anyways.
Yeah, that'd be good.
Basically, we're on to the Q&A, but I'm going to also like post questions if you have them. I'm going to hop over and I'm going to show like some of the doc stuff. Basically, like with vCluster, you have like, okay, yeah, it's about you post
right there. Just to let people know that this is what we're talking about.
So like you just have all of these other. It's not gonna be in here. You have all these other options within like the vCluster YAML to be able to sync stuff up and share stuff from the host cluster, or by default like you don't share much of anything, right? Like so. The user would go in and they would use a virtual cluster and they would think that they have their own Kubernetes cluster. They see nodes, they see all this stuff. They don't realize that they're running a layer up, but it just depends on what you want. You can use whatever you're already using. Like if you want to isolate stuff on the host cluster and lock down with like network policies and stuff like that, you can use that. If you want to go a layer up and just use the built-in stuff from the isolated virtual cluster option, you can do that too. We have some templates and stuff like that we kind of show off in the vCluster platform, which is the enterprise product that you could kind of use as an idea for what you want. Yeah, the defaults are pretty good, right? Like it depends on what you want to share. But then you have all of these. Okay, so with vCluster itself, there's these options that are enterprise. Those are the paid options. Everything else is open source, right? Like so, almost for the most part, most of the configuration options are open source. The stuff that's enterprise is like the nice to haves that make it super easy, like to get started day one.
But it's super easy also to see. I love how whoever made that decision on the docs to tell me, hey, this is the stuff you got to pay for, right? Like rather than being like, oh, I get so excited about this thing and then realize, oh, wait, now I have to pay for it. And so it's like, no, these are the things, bam, 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 bam. And so it's straightforward.
Even some of these paid stuff just takes like custom resources. Like we made it super easy to be able to do it because like everyone's, running cross-plane or something else. There's still ways that you can do it, right? Like if you are an open source power user, you can do it. We just make it faster and give you some of the nice to haves. Like we also have the option to have a hosted control plane, right? Because we're talking about GPUs. We're talking about making sure that everything that's running on your bare metal nodes with those GPUs is a workload, right? By default, the open source version of vCluster and even the paid version of vCluster platform will run a virtual cluster pod on that node, right? Like so that's +1 for every single workload that you want to run in a virtual cluster. Unless you run like 50, workloads in that virtual cluster, +1 for each of those, right? So if you really want to hyper optimize, that's going to be like the enterprise version. If you just want to be able to run stuff and get stuff done, that's going to be the open source version that's going to have like the +1, right? So people ask, oh, how much overhead is there? The overhead depends. All right, we'll go into this too. So we've been making some diagrams and stuff about like different storage types and stuff to back virtual clusters. So one of the things that kind of spurred this conversation about bare metal and that kind of thing is a potential customer and a customer like came up to us and they were like, hey, we're running into issues with SQLite. We're backing our virtual cluster. And we're like, oh, okay. So like, what are you doing? They're running like so many workloads in that virtual cluster and they're giving access to like 20, 30 users or something like that, which is it's not what we basically sold vCluster as in the beginning. We're talking about, hey, these are ephemeral environments. These are dev test preview and stuff. It's also prod and you're running SaaS and stuff in it. But the default is SQLite. It's a SQLite database, which is not enough if you're running multi-tenant, on top of bare metal. So there's other options too, like etcd. You can run etcd in the same namespace. You can run etcd embedded, so within the virtual cluster, or you can run an external database, right? So some of these things that we're thinking about and talking about now, we weren't even thinking about like a year or two ago because there's all these new use cases. But you want to go in like and play and stuff. It's like the first time you deploy a virtual cluster, you do SQLite and you're gonna mess around with it. And if you do some load testing, you might be like, okay, SQLite's the bottleneck. Then you switch to etcd. So there's I don't know, Scott, I'm rambling now. You want to add anything? I think you're about to say something.
No, I think it's handy, right? So I think it's smart to start with SQLite because you want to keep things as light as possible. All of my virtual clusters that I'm running in my home lab are using the SQLite defaults. But being able to take things into production, like say, because one of my websites downstairs is actually a website that we hope will, gain traffic and get a lot of people using it. And so at some point we could swap out that SQLite and have more of an etcd data store. And that's simply built in, right? All we have to do is change a configuration.
Yeah, we're into the what is the vCluster section of the presentation. If you didn't know, we'll go back, ask questions if you want. We're gonna go back to the slides after we finish this and then show like vNode. But basically that's it, right? Like so. The customer asking that question, we're like, oh, well, you're going to use etcd or something like that. I think some people are spinning up etcd per virtual cluster, and you're going to have different use cases when we're talking about bare metal. Whereas like the first time you use it, it's going to be SQLite, and then like you can keep using SQLite for ephemeral stuff. Like don't change anything. This is just kind of coming off here. I like the defaults in, right? Like the defaults are SQLite, very low to the ground, run like a workload or two in there, like try like a preview environment, test it out, and then when you want to actually get into something that's more difficult, we have different options. We have like the enterprise options, and then we have the non-enterprise options that'll still give you the ability to switch to like etcd or something a little bit more advanced. All right, cool. So basically that's vCluster. All these, to answer your question, Game Over Dave, in a very long-winded, all over the place thing. There's a lot of options that you can configure. Most of them, like I'd say like 90% of them, that's not a hard number, but 90% of them are open source, and you can get away with doing a lot of stuff with the open source. It's just when you want to start supporting additional users in your environment, if you want to start having, like larger virtual clusters and that kind of stuff, and you need support, that's when you kind of look at the enterprise, and it's going to give you like a graphical interface, like a UI, and make things easier. Yeah. So that's vCluster. Like vCluster, if we go back to the image, where's my, not the configure, where's the quick start? Here, let's do this. It'll take me right back to the quick start. So that's basically what vCluster is, right? Like, yeah, understand. So hopefully it makes it entertaining, right? Because it's not like you're going to be bored about me talking about the same thing for more than like a minute or two. Like this is the idea.
Keep going.
Yeah. Well, so we had feedback on one of the webinar stuff that we did too. It's like, hey, what is vCluster? Like we assume that everybody that's coming in here might know what vCluster is, but maybe you're just a Kubernetes user. Maybe you don't know what vCluster is and you haven't used it, right? Like so, the idea of vCluster is I want to do multi-tenancy. I want to do preview environments. I want to basically spin up a Kubernetes cluster in a minute or 2 minutes. I don't want to spin up something on EKS. It's going to take me 30 or 40 minutes so that my developer can just hang out and do whatever. I want them working. So like virtual cluster is going to be like within like 60 seconds or so. It still consumes resources from your Kubernetes cluster, meaning that it's still running in the Kubernetes cluster. We just bring a pod up that has an API. It has its own backing store, right? So you can store your own CRDs and the resources that are in there. And then what it does is it syncs. It actually syncs to the host cluster. So it's using Kubernetes. It's Kubernetes in Kubernetes, right? Yeah. So it syncs to the Kubernetes cluster instead. So you don't have a hypervisor between it. You're not doing like kubevert and then running a virtual machine and then running pods on top of that. You're literally doing Kubernetes in Kubernetes. We just kind of make it so that you can segment it out to where you're not just using namespaces. So it goes beyond namespaces. Because everyone, like if you're just doing namespaces, your users can't install their own version of, we'll say MySQL in this case, right? Like, because we're just talking about VM people. They can install their own version of MySQL. They have to use whatever the global version of MySQL is. But with virtual clusters, they can install their own version of MySQL, right? Like they can install and test their own version of Nginx. MySQL is not the actual answer. It's just like trying to like make it like easy to think about for VMs. Like they're not installing their own version of MySQL. Maybe they are. Maybe they're running their own pod of it or whatever. But we're talking about CRDs. They're installing their own version of Nginx if they want to, or they're sharing stuff up from the host cluster. Backups. Okay, so it was like people were using Valero and stuff too, but with the last release, there's actually snapshot and restore, right? So now instead of just using Valero or something additional, there is a vCluster option for snapshot and restore. What it'll do is it'll take a snapshot of the virtual cluster and then it'll back it up to whatever image repository that's OCI compliant that you want to back it up to, right? You can you can get it locally too, but for the most part, all of our backup restore stuff assumes that you have some kind of image repository where you're going to save it. Like I put it on Docker Hub or something like that. So yeah, so you could use Valero, but there's backup restore now built in, and it's in the command line, and you can use it for that. And it'll save the state and everything, and then you can either create a brand new virtual cluster off of that backup, or you can restore in place, right? Like it's gonna restart the virtual cluster that's running if you're in store in place. So that's something to think about. All right, so yeah, so Syncer, I don't know, Scott, you got something to say?
Syncer is, I've been using the Syncer to essentially, I install an ingress controller onto my host cluster, and then I don't have to install it on any of my virtual vClusters. And so then I don't have to sit there and do a Helm chart install every single time. I just go in and I configure my ingress. It's super nice. You basically tell it in a file called the vCluster config file, which is what you pass in when you're creating that vCluster. And it makes it simple, easy. And it's syncing those things, but not syncing everything, right? So it only syncs the things that you need inside your virtual cluster. And then
that's what we bring up, right?
Like, ingress classes are built in, right? The custom resources one, that's part of enterprise. So if you have more custom resources then besides things like ingress, then that's part of the enterprise product.
Besides ingress, besides like config maps and like all of the basically the built-in stuff, like the custom resources,
right? I think secrets and config maps were a recent addition to the open source.
So like they're like talk about vCluster. There's like 3 things that you can't create in a virtual cluster that you're going to share with the host cluster, and that's going to be storage. It's going to be the container runtime, and that's going to be networking, right? So you need to be able to sync some of that stuff up to share with your users. Like they need to know the ingress class. They might need to know the storage class if they're creating different types of storage and you got multiple storage classes, right? They need to know that stuff. So like what you can do is you can, the one that we like always talk about is you can run Nginx as an ingress controller on your host cluster and a single load balancer, and then share that up, right? Because if a user is creating an ingress resource, then you know the ingress class unless you have it set to default. And then what they can do is in their virtual cluster, create that ingress resource and reuse all the stuff on the host cluster. So instead of giving each tenant or each user their own load balancer, you're just sharing the ingress class or sharing the ingress controller and the load balancer on the host cluster, right? So that'll save money, especially if you're using EKS or something like that. You'll just have that single endpoint, and then you can do like a wildcard or something like that for the subdomain for whatever domain you're using. And then your users can use those if they need to expose it or share it with someone else, or even internally. Same idea, right? Like you can do an internal host name, and then they can actually have like a host name and get certs and all that stuff. So you can share all that stuff up. Cert Manager, you can share that up from the host cluster. Basically, so I don't have the slides where like I'm upselling vCluster, right? Because this is more so about like why move from VMs to bare metal. But a lot of the stuff for vCluster, like it makes so you can manage the CRDs in a single place and then share them up instead of having users install all their own CRDs. But on the flip side, they can install all their own CRDs and stuff like that to do testing. All right, cool.
That's the one piece that caught my attention when I was learning about vCluster, was the fact that I could have one place where I install all those CRDs for everyone, and then everyone can just use them if they want to, but they don't have to. And that versatility, that's when the light bulb moment. That was a light bulb moment for me. I was like, oh, okay, this is cool. vCluster is pretty cool.
So I told Scott that we're going to do like 30 minutes, but we're coming up on an hour, and we'll keep going for a little bit.
If you have questions and you keep sticking around, I say we stick around. So I'm good.
So like post questions in there. Like so far, we've had some kind of takes on like the movement from VMs to bare metal and like why we think you should. Mostly, it has to do with like, how do I keep closer to the machine? How do I access GPUs and all of these new things that have come into where like everybody, like every company out there, especially larger companies, are doing their own inference. They're building their own models, right? Like I was so surprised at when I was interviewing for places around like 2021, and I was so surprised at how well companies that I wasn't thinking about were already doing Kubernetes, and they were already crunching their data and looking for stuff that they could actually optimize based off of that AI stuff. It's also kind of scary because like you look at Shein and stuff like that that's using real-time data to figure out what clothing is important enough to like create it so they can sell it in real time. And that's a lot of like waste, but still like all these companies are doing it. They're already using it. Like I've avoided getting too deep into AI, ML, and that kind of stuff and interact with GPUs. One, because after 2022, it was super expensive to even buy a GPU, right? Like now we're kind of getting to a point where you can go get them. I literally bought a 570 Ti at MSRP, which was crazy to me. Like I didn't realize I could do that now. So I went ahead and did it. You can buy GPUs again. You can play around. You can test it. Framework's got like a really cool desktop coming out that you can do local LLMs and stuff like that. Now, here's the thing for you, Scott. Like I thought it was super cool to do local LLMs, which maybe other people have, comments on this too. And then I looked at how many tokens you can get a second with a local LLM. And guess how many tokens or words you can get a second with a local LLM? 128 gigs of memory, like super fast CPU, a lot of GPUs. How many words can you get a second, you think?
No, I don't even have a reference because I do remember like the remote ones. So how many?
Well, like ChatGPT, right? Like you type, write me a novel or something like that, and it just goes and it's quick, right?
Yep.
0.87. Like I looked at how much you say 20. No, it's like 0.87 words a second or tokens. So a token could be a word, letter, or something like that. But like 0.87. So I'm sitting there asking it to write me like a 60-word thing. It's taking a minute for a local LM. Now that's cool because I can actually use it, but it's not nearly as fast as using something like ChatGPT. So like I was surprised by that. So like
that just opens your brain to the fact of how much power they have running if they can get that response back to you so much faster. Like all the different LLMs, not just OpenAI. That's fascinating. So like
small models. So I'm talking. Okay, so let me background. I'm talking about like not the largest DeepSeek, but like the second largest that you can actually load into like the 128. Like I was reading Reddit and stuff, trying to figure, I want to buy one of these things. I want to use it. And then I looked at how many words I can get a minute. Like that's not fast enough maybe it is fast enough for doing development, right? Because if you're developing, you're not really typing 100 words a minute. Like you're literally typing like a word or two, maybe like 20 minutes or something like that, depending on like how fast you're typing through. Like some people are like super fast at like coding, but for the most part, like you're only getting a couple. Like maybe I think when you're developing, Scott, what do you think like the least productive day was versus the most productive? Like least productive, you wrote nothing. Most productive, maybe you
least productive. Let's be honest. As a developer, like there are days where you sit there and you're staring at your code and you have no idea what's going on, or like the net new is 0, right? Like because you're trying stuff and it doesn't work and you're backing up, or you're putting in log statements and you're backing up, or you know what I'm saying? You just keep kind of spinning and spinning and spinning. And so that's that. But then like a good day, you'd get, I don't know. It depends. I mean, nowadays, with the LLMs and stuff, you could say, well, it's like,
just template it out and just go.
Give me a function that does this thing. That's like, actually, you gave me a scaffolding that I can really go with here. What I've been telling people, and it's getting more and more and more granular, but what I've been telling people is that you still have to know what's going on, right? Like you still have to have an idea of what that code is supposed to do and how it's going to work. Because if you just say, write this thing, and then you just try to run it, then you don't know how to debug it. It's like, doesn't really help you in that sense. And unless you can, kick around in the dark and figure out the answer. But is that more productive?
It's for the reviewer to worry about, not me.
And again, going back to how trends just kind of go full circle, we've just gone full circle. So I'm just going to write my code and pass it over to the reviewer. They got it. They can figure it out.
So your best days were deleting like 30 or 40 lines of someone else's work.
Right. And just like this person wrote 50 lines to do something that can be done in 2.
Yeah. I've just deleted all of that. So now they've lost it up. Okay. So
I haven't used Windsurf. Dave, you've mentioned Windsurf a couple of times for development. Are you familiar with Windsurf, Mike?
I haven't used it, but I'm more of a sysadmin who role plays as a developer. Like I have some commits and stuff into Knative and it's Go related and stuff like that, but I would not call myself a developer by any means. I'm a noob. I'm a complete noob when it comes to development. I don't understand. I can do configurations. Like I can do networking. I can work on Cisco. I can do Linux administration. I can write Terraform and all that stuff.
Right.
But something does not click in my brain when it comes to Go development, and it takes me forever to get through. I mean, maybe that's all developers. Like it's just like that. I don't like the process of spending 2 hours to do like 2 or 3 lines or like 2 or 3 updates, right? Like but that's the norm, right? That's the norm for developers. But for me, it felt like I was failing. I don't know why. That's just my brain feels that way. It's like to move on from tasks.
What I love about development is the fact that there's a couple of different things. Development is like any sort of skill, whether you're like a musician or an athlete. If you're not doing it consistently, then no, you're not going to be very fast at it. And so if you got to have the habit of doing it every day, or at least very, very often. And that is one of the things as a developer advocate, that's one of the things that I'm sad about, because it's like, I try to get into code as much as I can, but it's not every day. It hopefully is every week, but like, it's, but also like you have to be willing to like love trying to dig and dig and dig for, an answer, whether it's in your code, right? Like if you're just like, I don't understand where this thing is broken, and it's like debugging a thing. I mean, debugging is really 95% of what development is debugging the code that's there.
The payoff's awesome, right? Like after
The
putting all
payoff,
that time in, like the payoff
there's
of working.
nothing feels better than like getting something to work that you've been struggling with, right? Like it's just like and everybody who's done it understands. Like you throw your arms up, you're running around, you're like, yeah, this is the best.
What annoyed me, I think, about like, so you romanticize development and stuff when you're growing up, and you're like, oh, I'm gonna go into CS, I'm gonna do, you know, computer science, I'm gonna become a developer.
I'm gonna build the next greatest big thing.
You realize I'm just redoing text in different ways and taking text and doing different things with it and like changing it around, reformatting it and using it to input somewhere else. And it's just like all these, like, I'm just doing stuff with like text inputs everywhere. I mean, you're doing more than that, right? But it's basically a lot of it's that. And you're like, well, this isn't as interesting as I thought it was going to be. Like, I want to go manage Linux machines and play with Terraform and play with Ansible and do all these things that consume what these developers have created instead, because that's the payoff, I guess, is a little bit faster for me. I don't know. And then when you write something, you don't know if anyone's ever even going to use it, right? Like, and then depending on what project you're using, so it's like, is this worth it, right? Like, I don't know.
So many times I've written something that I'm like, I don't bet no one's ever used this. I mean, yeah, I could go into stories, many stories. But
regex machine, yeah, like say that's right, Dave. Just your regex machine, just do it. And it's like in my head, I couldn't think of it in a way that made it easier for me, but that's because I didn't practice it enough too, right? Like if I would have practiced it more, maybe it'd be more fun. But that's my background. I'm the infrastructure, Scott's developer. We're meeting in the middle.
We kind of come together and kind of have a bigger picture of everything. So,
all right. So let me,
Dave, you have a lot of great comments. Thank you.
Yeah. Thanks for interaction.
Appreciate it. If you want to see Dave's comments, they're on YouTube. If you're not watching on YouTube. So.
Yeah, I know we're not posting all of them too, because Dave's got some good stuff. I don't know if Dave wants to like have his image and stuff up on there too. But
that's true. I never did ask Dave. Do you want your image up there?
That's okay. Wait. I don't think we saved the comments on YouTube. I think I've got that off. Maybe I'll turn that on for like the next couple of ones. All right, no worries.
He's all good. All right, that's good.
This is our live stream, our Twitch stream, or YouTube stream. Like, I keep thinking about like what I like to be a streamer. It takes too much time and dedication to be like a real streamer doing it 5 days a week. So like I feel admiration for people that can do that, because it's so much work. I like doing it like once in a while and coming on.
There's a lot of work that goes around the shows, right? Like you see them on the shows and they look like they're just nonchalantly talking about a thing. But there's so much research that have gone into that and how they're talking about. I mean, honestly, even our conversation today, like the research that you and I have done, the years of experience you have, the years of experience I have, the fact that we're doing that, talking about bare metal, talking about virtualization, it's all the culmination of all that preparation beforehand. So it's a lot. So, and Dave thinks we're doing great. So I thank Dave very much. So.
Working in the tech world too, like I've been wrong so many times, and there are people out there that will tell you how wrong you are, and they will make sure that you know that you're wrong. But like, so that's why
I was kind of hoping somebody would tell us we were doing wrong today.
Yeah. Oh, we'll get in the comments. We don't claim to be experts on anything, right? Like anybody, there's always room to learn more, right? Like there's always new things. Like we've learned a little bit, and it's like I don't know anything. Like I feel like I don't know anything, and I've been working in tech for like 20 years, right? Like so, I'm still learning stuff every day. I've been resistant to the GPU and AI stuff, right? Like till now. Like now I'm going to start playing around with it. I've done a couple of things. I've done some image recognition. I've done character recognition more so than image. I've done some stuff with Jupyter notebooks and stuff, but I wouldn't call myself an AI ML person. I use ChatGPT here and there. I've been making the Ghibli images and stuff like that. But like for the most part, like I'm not using it every day yet. I'm still resisting, but I'm getting a little bit more used to using it too. I don't know how many of y'all are using ChatGPT for like everything. Some people are telling me they're not even Googling anything anymore. They're just ChatGPT in, which some of it's wrong, but most of it's close. And it kind of gets you there.
It helps. It takes away that blank page problem.
Yeah.
Right. It gives me something to work with. Most of the time, like if I prompt for something, like if I'm about to write an article, like the article that I'm publishing this week, it's like I put a prompt into ChatGPT and was like, what it spit out, I was like, no, but it got me thinking about another idea. And so then I kind of went with these other ideas over here, but at least it gets you moving. It's the dangerous stuff is when you're just like, oh, yep, that works. Copy, paste. I mean, I've totally seen blog posts that I'm like, that is straight out of Jet. Like they didn't even edit the thing. Yeah. Like it's literally in the same format. You see all your ChatGPT responses in. I wanted to go back to what you were saying about feeling like an amateur, right? It's like no one knows all the things about all the things.
Yeah. Like if they pretend like they do, they probably don't.
Right. Exactly. And the more you know, the more you realize you don't know. So when someone says they don't know anything, they feel like they don't know anything, then they're obviously pretty smart because they realize how much they don't know. So there you go.
Well, like the first time you touch Kubernetes and you start using it,
Oh my goodness.
it's like, oh, I know all this stuff. I can do all this stuff. This stuff's super easy. Well, it's been trivialized in a way, not for the platform team. A lot of stuff's been trivialized to where like I'm not going in and editing an Nginx configuration by hand anymore and setting up virtual hosts and that kind of stuff. I'm just describing it in Ingress, right? Like, so that's what like some people that are like, I'll go into a story, a personal, not personal story, but like one of the dads that goes to school with my daughter stuff. Like he retired probably like in his 30s, like 20 years ago, right? And talking to him about the technology that's been happening over the last 20 years, because it's like a time capsule. He's time capsuled in that time, and like just be able to explain like all the new stuff to him, and like he's like, oh, this is like too much. It's like, no, everything that you were configuring by hand 15 to 20 years ago is now just described in YAML, but you still have to know some of that stuff, right? Like there are people that are going into those Nginx containers and looking at the logs and seeing what's going on if something breaks, right? Like, so still a lot of the same overlap with the like, stuff we've already used. It's just, it's different now, and it's abstracted, but you know, SREs and stuff like that for Kubernetes, no, you're still troubleshooting kind of the same things, but I don't know, maybe most of the time, like you get the root cause and you just delete it and let it recreate instead of you spending, you know, weeks into like figuring out what the root cause was. I don't know.
Which kind of comes back around to our points, right? About virtualization, because with technology, the more it evolves, the more that we develop things, we're abstracting out the mundane. Yeah. So virtualization was abstracting out the fact that we didn't want to be working with the hardware specifically, and we wanted things to be a little bit more flexible. And so we made a virtualization layer so that we could have more flexibility, but then it came with a cost. And so with bare metal, yeah, there's still a cost, but you're abstracting out other things. You're abstracting out the tedious configurations of configuring Ingress or configuring the other thing, like things with your containers, like with Kubernetes and things. Now it's all described in YAML because we all live in YAML every day because that's what we do. But before, we had to know lots of different configuration languages or like places to configure things and how to, you know, twist the nerd knobs to make things work. And Kubernetes kind of gives you that space to have a common language.
Plus, you also had some of these appliances and virtual appliances and stuff that were hard to get because they're too expensive, right? Like, so VMs made it, that's what I tell people that are trying to get into tech. VMs made it so that you can play around and do stuff easier, right? Containers made it even easier. And Kubernetes abstracts so much away that you can even do more complicated things that you wouldn't actually be able to do maybe 10 or 15 years ago because you didn't have access by yourself in a home lab. You didn't have access to, you know, like these firewalls that were super expensive, Palo Alto firewalls, and then the software licensing and all that to be able to configure and set up all the port forwarding and messing around with, I don't know, doing A/B testing and stuff like that. Now you got Istio, you got like all these things built into Kubernetes where you can play around and test this stuff, and it's still complicated. So like say Istio, a lot of people's eyes glaze over because Istio is complicated, right? Like there's still some complication to it, but it still makes it easier than having to go learn 50 different interfaces to be able to do the thing that you want to do. Like I got to go touch this F5 to set this up, and then I got to know where the traffic goes between that and my network stack. Like, does it go to like this switch, and then like how does it go to the node? Like all that stuff, right? Lots of stuff.
How do I easily replicate my application because it's getting so much traffic? I need to have multiple replicas and have a load balancer in front of it. Oh, now I can just like flip switches inside of my YAML and it's done. Right? You don't have to think about what's happening. You're just like, oh, it's just now it's spinning up multiple containers on my multiple pods with my multiple containers. And now it's my applications is just a little bit more resilient.
Say installing Kubernetes is not satisfying compared to installing other systems because it's much easier. Right? Like I installed I installed Kubernetes after installing OpenStack for years, and I was like, I didn't do anything. Like, well, does it work? Did I install it? I don't feel like I did anything. I just installed like 2 or 3 things. I didn't set up like databases. I had to set up MySQL databases and connect in and do all this other stuff. It's pretty simple to get it set up. And then it's very complicated. It can get very complicated very fast. Like if we looked at that one slide image. All right, so let me talk about vNode. I know we're getting over time. If you want to hang out, keep hanging out. I'm going to talk about vNode, and then
the viewers keep coming though, Mike.
Yeah, we keep people.
We keep getting more and more people watching. So I'm good if you're good.
Hopefully we're entertaining you, but also informing, right? Like I want to be entertaining more. I love like Tim and Eric type marketing and Nathan Fielder and Nathan for You. I don't know if anyone's watching some of the new Nathan Fielder stuff. I won't get into it. It's been pretty good. Pretty good marketing entertainment. All right. So basically vNode, I'm not going to go too far into vNode. Like vNode is a way to add security, like security layer to where you can actually make sure that you're not able to escape stuff. And like we have some comparisons, you know, saying like what vNode is versus Kata containers and gvisor and Sysbox and stuff like that, and why you want to use it over one of the others. But the idea is like if you're using vCluster already, and you're thinking about using, bare metal nodes, and you want that security, just basically go to the vNode.com and then, try vNode, and it'll reach out to our people, salespeople, and they'll give you like a license to try it out and stuff if it fits your use case. So vNode, there you go. All right, and then the vNode, like we've got documentation kind of showing some of how it works, like what it looks like to deploy vNode, and then what it looks like to actually run it on there, right? Like it's running on all your Kubernetes nodes and stuff, and it's using Kubernetes below the curtain, not curtains, but
under the covers.
Basically under the covers. There you go.
All
right, so what do we have coming up? Like, so something that's coming up on the 28th that you can check out. So this on Tuesday, we've had 2 webinars this week. On Tuesday, we did a webinar with Linux Foundation, and if you go to the Linux Foundation's YouTube channel, you'll find it. It was with Artem, and we're talking about vCluster and doing all kinds of things with that. But we have another webinar coming up on May 28th at 4:45 p.m. Pacific. That will be on the YouTube channel too after it's done. So the Linux Foundation's YouTube channel will have this video, but it's going to be with our CEO Lucas and Michael Norris. So it's going to be talking about moving from 195 VMs to 1 bare metal Kubernetes cluster. So while we've just been kind of talking at like a high layer about all this stuff, if you want to actually know how it's done, this is how it's done. I'm going to post this link, Scott, and I'm going to be quiet so you can talk for a minute.
Great. Yeah. The folks at Aussie Broadband, which I understand if you're in Australia, they are basically the backbone of everything there. But they, as far as communications goes, we'll put this link up here to grab that. Although we should have a QR code or something. But yeah, go find that on the Linux Foundation website, the Linux Foundation webinar. The conversation between Lucas and what was his name at Aussie Broadband?
Michael Norris.
Michael, sorry, Michael. So yeah, the conversation between Michael and Lewis will be fascinating. I've only heard bits and pieces about the story, how they went from a huge number of VMs down to 1 bare metal cluster, how much time it saved, how much money it saved. And so that's honestly where, for me, sparked the whole idea of like, okay, need to dig into more of this whole bare metal and virtual and story, and to see what is there, like, and for them, it's just the efficiency, and especially the money, the cost of running on bare metal as opposed to running into a virtualized environment. And from what I understand, and the research has shown that you have about a 30% overhead when you're running in virtualized environments. And so you have a 30% of all of your processing is going into running the virtual machine, and then instead of running your workloads. And so 30% is a lot, especially when you start going big, like an entire country running their communications, backbone type stuff. So that's super interesting. I hope to catch that. That's in what, a couple of weeks?
May 28th. So
May 28th.
13 days. So not
that one.
This week, next 7, I can't count. Yeah, next week.
Yeah,
weeks. 2 weeks. Yeah.
Yeah.
So looking at the date again, looking up there, the 15th. Yeah. I don't know. All I'm thinking about is June 5th, which is the switch to release date. And then I'm trying to figure out how many days are between here and then. And that's 3 weeks. So I don't know if we get to switch to. From last time.
Mike's got the switch to on the brain. The man has asked me multiple times if I'm going to get this console. And to be honest, I am sort of tempted because I haven't gotten a console yet since my small days, my youth days. And maybe this handheld device may be a thing that I want to do.
Well, my daughter's super excited about it. She's always like, can you put the number 2 Switch videos on YouTube? Like, they're excited about all the new games stuff coming out. So like, kind of looking forward to it too. Yeah, like it's been a while. It's been a while. I think the last time that I bought a Switch, well, the first time I bought a Switch, I was running on virtual machines. I don't know if I had yet touched Kubernetes. I was doing OpenStack when the first Switch came out. 2016, 2017, and then switched over to Kubernetes from there. Hey Dave, thanks for stopping in.
Thanks for stopping by, Dave.
We'll be on here again. Hopefully we can make this a more consistent thing if it's enjoyable for people and they're learning stuff.
I'm going to definitely check out Windsurf. He told me to check out Windsurf. I'm going to go look at that. Put on my list.
But yeah, so let's go ahead and we've been on here a while. Let's go ahead and wrap it up.
Sure. Y'all have been great. Thanks all for sticking around and for listening to us. Where you can find me, if you like this conversation where I've been talking about VMware and bare metals, or not VMware specifically, but virtual machines and bare metal, I'm going to be talking about it in New York in a couple of weeks. So at KCD in New York City on June 4th, I'll be talking about are you VMware-y? And so basically posing the question, you're using VMs, but is that what you
should be doing, and kind of talking about some of the history behind the different pieces, things like the history of hypervisor, VMs, Kubernetes, containers, microservices, monoliths, all that fun stuff, and then posing those questions and allowing you to think about those things about your particular environment. So I'll be doing that in New York City. I'll also be sharing that same thought in Kansas City, about the following month at the Kansas City DevOps meetup. Come join us over there. And then at Nebraska Code, I'll be talking about end-to-end testing. So talking about using Kubernetes inside of an end-to-end test where you're going to be testing your web applications. And so you can see that there. We're using ephemeral environments. So I'll be talking about spinning up a K3s environment inside of a GitHub action, but then also integrating that in with vCluster to really test out your code and your applications. And so I'll be doing that at Nebraska Code in Lincoln, Nebraska in July, and then also at Kansas City Developer Conference in August. It looks like I like to live in the Midwest. When you look at this list of things, it just happens to be that's what my schedule's like. But the Midwest is awesome. There's a lot of great companies there, a lot of great developers there. It's not just flyover country. I'm also from there, grew up there, so it is home. So come find me there. Come say hello. I'll have some stickers and other swag. So come say hi and hear a little bit more about what I have to say. So that is where I'll be basically through this summer. And Mike left me. But so what we'll be doing here is hopefully we'll be having a few more of these shows coming on regularly where we have either Mike or myself.
Sorry, I got knocked off for a second.
You're all good. You're all good. And so we like this format where we chat about a topic. We'd love to hear what you have to say, what you're experiencing. If we're crazy, right? Like if we're like totally off base and completely saying something weird, tell us and be like, well, actually, this is what I see from my experience. Because we're all in software. We completely understand that, hey, everybody has opinions. Really, everybody does. And so come here, share your opinions. But
join the Slack community.
I was gonna say, if you don't want to jump out and talk on the show with us, come chat with us in our Slack community. So over on slack.vcluster.com, that is where you'll find us. Mike and I are there every day. We love chatting with folks who have questions. If you want to just come talk about things, talk about virtual machines and bare metal, we love to talk about that. There's a channel for end-to-end testing because we talk about that enough where we have ephemeral environments with vCluster that end-to-end testing in general should just be a topic we could discuss. You can come find our end-to-end testing channel there over on the Slack workspace. And then you can also schedule a demo if you go to vcluster.com/enterprise-demo. Mike, you want to share more about that one?
Yeah, that's just with our sales team. Like if you want to do a demo and see how things work, we have some videos on our YouTube that kind of show like what the demo will be. Like if you want to see how to use vCluster and use GitOps to deploy virtual clusters and add users and stuff like that, you can do that. Basically, if you want to see what's ever like up with the enterprise, we also have like weekly demos. They're called weekly demos. We've been doing a lot more other webinars and stuff too. So like I haven't been doing it every week, but we probably will start some of that up again in June. Like if you just want to see what vCluster platform is, we'll have some weekly demos. But for the Slack stuff, let me go back to. So yeah, join us on Slack. But then also, like say you just want to, you're a little bit interested in vCluster. You don't want to have to join the community yet. Like you're not that far along. We do have a vCluster channel on the Kubernetes Slack too. So join us over there and post questions there. We do interact there, and we can help you out there. So I know everyone's got like 50 Slacks, right? Like, so they're like, I don't want to join like another Slack. I don't want to join another Discord channel and all this stuff too, because it's so many notifications. Join us on the Kubernetes Slack if you want.
So if you're already on the Kubernetes Slack, there's a vCluster, like Mike said, vCluster channel. We're there. We usually post links to these types of shows.
Yep.
So, and we're also there to answer questions and just chat about things. So
we prefer you to join our community, but yeah, there's also other options.
Wherever you want.
All right, cool. So basically, thank you. Thank you for joining. Hopefully that was informative and helpful. We didn't want to make it too, bogged down with slides and ridiculous kind of showing like way too much information. We want to kind of make it interactive. And thank you so much for interacting with us. We'll be back. We'll be back again. We'll post. So we do have an events page, but also every time that I do one of these, it'll post on our YouTube and LinkedIn as an event that's coming up. So just follow our LinkedIn, subscribe to the YouTube, and you'll see the stuff that's coming up, right? Like I'm going to post another one. We got something else coming up next week. So keep an eye on that. And
like and subscribe, as they say.
Yeah, like and subscribe.
Yep.
Well, thanks so much for joining me, Scott. You got anything you want to say before we head out? So
really grateful to have you all with us today. We went way over time on what we originally forecasted for, and we stayed because you stayed. And
because you're here.
We're grateful that you all came, and let us know. Let us know either in this chat or on Slack. If you want to hear other topics, other types of topics, we would love to talk about what you want to talk about, because that's what we're here for, is to provide a resource to the community that is a place that you want to come and place that you want to learn. So come over to our Slack or post on the Kubernetes Slack for vCluster and let us know what we can chat about, and we would love to share with you.
We can do demos too, right? Like,
yes,
happy to do demos. Hopefully we'll have a GPU related demo in the next couple of weeks.
I want to see that from you, Mike.
Yeah.
I'm
my hair's gonna be a little bit grayer, right? Like I'm gonna be a little bit more maybe like my facial hair is gonna gray up too, because I'm gonna come on and finally got it to work. Yeah. Well, like that's the thing. The thing is, talk about it for another minute. Maybe we'll let our house.
Right.
The thing about the AI stuff and like GPUs is like done a lot of stuff with infrastructure and all that too. Maybe a lot of you have too, like done a lot of infrastructure stuff. It's like where, like the ChatGPT thing you're talking about, where do I start?
Exactly.
Like, so that's where I'm going to go. I was like, where do I even start to get interested in this? What am I even doing? Like I've done some things like where we've done character recognition for like a Fortnite stream to see like who had the least amount of people in their match still, and then sort it based like on a red zone type thing, like football. Like I've done some of that stuff. Like that's an interesting, like I've got a use case and I actually can learn to do stuff. But like where do you start? ChatGPT gives you the questions you didn't know to ask, right? Like, so what for AI ML, like in GPU, what are the questions we don't know to ask? Like, am I training stuff? Am I using it for local LLM? Like what are people doing with it? Like at home, right? Like in their home lab, like what are they using it for? Or is that too expensive to do, right? Like Scott, like what are your questions about? Yeah, like I don't even know what to ask. Like what
I don't even. I'm at that point, right? You're at the point where you're like already buying hardware and things and talking about running your own local LLM. I'm at the point where I don't even know what to ask yet. Yeah. I'm barely just using it or thinking about how I can incorporate it into an application, right? Like have an LLM running inside of a model that I could use to write an application against, right? That's the kind of stuff that's probably where I would start. As a developer, I would want to know how I can connect into a service to answer questions or to provide or build content based on, a particular topic. And so that's probably where I would go first. Kubernetes was where I was
basically at this point, right?
Ago. I didn't know where to start. Oh,
I don't know what's going on. I'm too afraid to ask at this point, right? Like,
I feel like him most days.
Yeah.
Chris Pratt was great in that.
It's like that's the question. It's like, so hopefully answer some of that stuff this week. If you have answers for it, you want to post like comments on the video or something. Like, where did you start with it? Like, what are you actually using Kubernetes and GPUs, and what are you doing with it? Like, for the most part, the GPUs are super expensive to get. So even if you're working at a company that maybe has a couple of nodes with GPUs, maybe you don't even have access to it, and you're trying to figure out, what do I do with it? How do I mess around with it? Right? Like, or you're going through a service provider, right? Because the service providers have all the GPUs, but then you're competing apparently with like people like Microsoft and OpenAI to even get access to that, because maybe they're not even running internally. They're just using something like CoreWeave or I don't know. Like, I don't know, like they use, right? Like maybe they're actually consuming from there. So where do you get access, right? Like everything's very expensive. It's super expensive to dedicate your time to just get a node on like EKS. There's probably other options, I think, that are a little bit cheaper now that you can do with like the fractional GPUs. It's like, where do you start? So hopefully we can kind of fill some of that stuff in. And obviously we're going to add the vCluster flavor to it to show you how you can do it with that too, and give access to your users. But I think we're good. I think we're good, Scott. Thanks for coming in. Thank you, everybody. Watch our channels for like more information. Like, we're going to do this again. We're going to have more stuff. Like Scott's kind of newer here. I've been enjoying like doing a couple of these with him, and I'm going to keep doing them as long as he's interested. So
I'm in.
Hopefully it was entertaining for everyone else too.
All right. Thanks, y'all.
Thanks, everybody. See you next time.